Hello everyone. Today we'll be solving another Leetcode premium question. This question is really very interesting. As you all know, I've started a Leetcode premium question series. So in this I'll be solving maximum of the Leetcode premium questions of different tags. So this is another question which I'll be solving here, and this is really interesting. So you guys have already solved you guys might have solved already jump game 1, 2 or 3, 4. There are series of jump games. So this is one of the jump game, which is jump game 8, and this is a premium question. So let's just jump into the question and see what the question says and how, then we'll figure out how to solve this question. So the question is, I guess you have read this question. I'll be explaining this question in my way so that you can better grasp it easily. So let us see what the question is saying. So the question is saying that I have an array. This is given an array which is 3, 2, 4, 4, 1, and a cost which is 3, 7, 6, 4, 2. So these are the two arrays that are already given to us. So what the question is saying is, there is a person who is standing over here at the 0th index. Okay, so what I need to do is I need to make this person go from 0th index to 4th index in as less cost as possible. Okay, so it's a jump game, so I need to jump the person from index to index with the minimum cost, but the conditions are here. So the condition says, if I'm jumping from suppose position 3 to position 4, let's just change the color. So suppose we are jumping from position 3 to position 4. So what we are doing over here is we are jumping from index 0 to index 2, but the condition should be fulfilled. So the condition is, I will only be able to jump from index 0 to index 4 if my value at index 0, which is 3, should be lesser than, means value at 0, val at 0th index should be lesser than value at 2nd index or equal to. This can be possible, like if they both are if this value is lesser than this value, then we can jump from here to here. But there's one more interesting constraint over here. The another constraint is the value which is inside these two index. From here to here we are jumping, but the values which are residing inside this index should be lesser than the value which is at the ith index from where we are jumping. So these values, the value which are inside the index, should be lesser than the value at the starting position. So this value should be lesser than 3. So here I can see that 2 is lesser than 3 and 3 is lesser than 4. So it's the best possible scenario to jump from 0th index to 2nd index. So this was the one condition. Now the another condition is, okay, let's just take another example so that we can clarify it more clearly. So if we are jumping from index I to index j, suppose j is this index. So as we can see, 3 is lesser than 4. So cool, one condition is fulfilled, so we can jump from index 3 to index 4. But the question arises here, are the values inside this I to j, are those values lesser than 3? So as I can see, 2 is lesser than 3, well and good, but 4 is not less than 3. It should be less than 3. The condition says it should be compulsory. If there would have been a 3, if I remove this and I add a 3 over here, and if I say now that okay, this will I be able to jump, but still we are not able to jump because it's strictly saying that it should be the values inside this array should be lesser than 3. So we cannot jump, still we cannot jump. So so the first part is clear. What we are doing is we are jumping from position here to here on the conditions that the value at the ith index should be lesser than value at the jth index, and all the values which are inside the index should be lesser than the value at which we are standing. So this was the first condition. Now the second condition is very similar. The second condition says that if I want to jump from one position to another position, suppose we are jumping from 4 to 1. Let's just change the color and see. Suppose we are jumping from position 4 to 1. So the condition says the value at the index where we are standing right now. So we are standing at position 2 right now. So we are here. So we have to jump from here to here. So what we have to do is, if we are jumping from here to here, the value at the index where we are should be greater than, strictly greater than the value at the position where we want to jump. So this condition is fulfilled. And one more condition is there. If the value at the values which are residing inside the index from where to where we are jumping, the values should be greater than or equals to the values where we are standing right now. So this is very, very interesting. As you can see, the first condition was just opposite, and the second condition is also very similar but in a opposite way. So in this, what should be there, if the values, if suppose there is one more value over here which is 3, suppose 3. So now we cannot jump from this position to this position. Why? Because there is a value which is lesser than the value where we are standing. We can only jump to position where the values are greater than or equals to. If there would have been a 5 over here, then we are 100% sure that we can jump from position 4 to position 1, because the values that are residing inside this array is more. So till now we are well and good, we understood this question. If you are getting any problem, please rewind it and start from where you didn't get the question. I'm pretty much sure that you will get the question. The question is not very difficult. The approach is very interesting actually, I would say. So let's just jump into the approach. If you want to solve this question by yourself, try it, and after that we'll jump into the question. So the question so what the question is saying, we have to find the minimum cost. Now there is one more thing, that we need to find the minimum cost from jumping from here to here. We need to jump from here till here, and the cost should be minimum, and the conditions that are given should be fulfilled also. So in this case, what we will do is we will see, let's just run this, make this as a dry run and see whether this is working or not. So now, as in our first example, it is saying that jump from 0th index to 2nd index and add the cost of the index where we are jumping. It's not from where we are jumping, it's to where we are jumping. There is a little different in calculation of cost. Sorry. So from 0th position to 2 position, we need to add the cost of the position at where we are standing right now. So we are standing at this position, so the cost of this position will be added, which is 6. Now if I am standing over here, from here I can jump here. From here I can jump till here with a cost of 2. See, and the condition is also fulfilled. So at first the condition was fulfilled as my 3 was lesser than 4, and the values which are residing inside this index, these both index, should be lesser than the value at the start. So the value is lesser than 3, so it's perfect, so we can jump from 3 to 4. And again from 4 to 1 we can also jump because it is fulfilling the second criteria. So the value is this value is bigger than this value, it's perfect, and the values which are residing inside of it should be greater than or equal to the value where we are standing. So it's perfect from here also. So we can jump from position 2 to position 4 with a cost of 2. So if we are adding 6 plus 2, that is 8. So this is the minimum cost that we have got. And any other step if we want to follow, we won't be able to get the minimum, or even we won't be able to jump, because it will not fulfill our criteria. So now try and solve this question by yourself. Try to find out an approach if you want to. Else I am starting with the approach, how to solve with the approach. Okay, the first intuition what we will do is, we are seeing that let's just suppose we take the first condition and not considering the second condition. Let's suppose we are considering the first condition. So what the first condition is saying, we can jump when the value is bigger than the value where we are standing, and all the values which are residing inside of the indexes where we are jumping should be lesser than the value where we are standing. So this is the condition, first condition. So let us see what is happening over here. Now if I am standing over position 0, I can only jump to those positions which are greater than this value. Might be possible. I'm still not 100% sure that we will be able to jump over there or not, but there is a possibility that if we want to jump from position 3 to any other position, that position should be greater than the value at this position. That position's value should be greater than the value at this position. So if the value at this position is 3, I need to find some value or some index whose value is greater than 3. So if I can see over here, 4 is the value which is greater than 3. So it might be possible that I'll be able to jump over here. So as I can see, 4 is also present over here, which is greater than 3. But if we want to jump over here, it will not satisfy our conditions, because the value which is residing inside of it should be lesser than 3. So we cannot jump over here. So what we are getting an intuition is, which is, if we are getting a value which is greater than 3, we will only be able to jump at that position and not beyond that. Just think over it. Think. What I am saying is, if I am standing at position 3 and we want to jump to another position which is greater than 3, we can only jump to the closest value which is greater than 3, and not any other value which is more than 3, which is farther than the value which is greater than 3. Let us suppose we take another example, like 2 is over here, 5 is over here, 4 is also over here. Let us suppose this is an example and we want to jump from here. So we can see we can jump over here also, we can jump over here also. These are the two places where we can jump. But if we are jumping to position this, even though the value is greater than 3, but the values which are residing inside of it is greater than 3, but this is not fulfilling our basic criteria that the value should be lesser, the values inside of it should be lesser than the value at where we are standing. So we are getting an intuition is something like that. The value where we can jump is the value which is the closest one. Are you getting my point? This is the really interesting part. Now from 3 I can jump to position uh, value which is positioned at, sorry, the position which is valued 5. Okay. So now we are 100% sure that from 0 we can only jump to 2, and not any other value. If it is 12, 200, any other value we cannot jump, because if we are jumping over 200 also, we can see that there are values which are which are more than 3, so we cannot do that. That will disqualify our criteria, that will not fulfill our criteria. So that was the main crux. Now what will happen, each value will have can jump only to those places which are just greater than the value where we are standing. So 3 can jump to the value which is just greater than its value, which is 4. So 3 can jump to position 2. Now 2 can also jump to a position which is just greater than itself. So from position 1 we can also jump to position 4. We cannot jump to position index 3 or index 4. That will not fulfill our criteria. So from 2 we can jump to position 4, which is indexed at 2. So from here also I can jump to here. Now from position 4 I can jump only to position 4, because it is fulfilling our criteria, that the values should be, the I and j should be lesser than or equals to, the value at j should be lesser than and equals to, and the values which are residing inside of it should be lesser than. So there is no value that is residing inside of it, so we can say that it is fulfilling the criteria. So the value which is just nearer will be indexed at 3. Now this 4 has no value which is more than this, so I'll just simply add a -1 and add a -1 over here, because there is no value which is more than this. So we can see this, what is happening, it is finding the next greater element. It is nothing but the next greater element. Okay, now talking about the second condition, let's just see what the second condition is saying. Second condition is just very similar but in opposite way. So in opposite way, what we are saying is, we need to find a value which is lesser than the value where we are positioned. So if we are positioned at 3, we need to find a value which is just smaller than 3. So 2 is a value which is just smaller than 3, which is indexed at 1. Now in this case also we cannot jump to 1, as this value is also lesser than 3, but we cannot jump to this position, because if we want to jump to this position, the second condition will not be fulfilled, as the second condition is saying all the values which are residing inside of it should be greater than or equals to the value where we are positioned at. So 2 is a value which is lesser than 3, so this condition is not fulfilling, so we won't be able to do it. So let's directly, what this means is we need to find the next smaller element. So the question is a bit simplifying itself. The question is saying something from itself only. So if we can see, the next smaller element of 3 is 2, which is positioned at 1. So 1 can be written over here. For 2, the next smaller element is 1, so which is positioned at 4. So from here I can directly jump to index 4. Now from position 2 I can jump to position 1. So from position 2 also I can jump to position index 4. Now from 3 also we can jump to index 4. And now from 1 we cannot jump any further, so it's -1. Let's suppose it's -1. Now we got these two things, next greater element, next smaller element. Now what we need to do is we need to minimize the cost. We still haven't touched the cost part. So now we need to minimize the cost. Now we know that from position 2, there are there are two positions where we can jump. Either, okay, let's just change the color. So for this is my index. So for position 0, either I can jump to position 2 or I can jump to position 1. So these are the only positions where we can jump. Think over it. These are the only two positions where we can jump. This is the best part. Now we are simplifying the question as much as possible, and the only thing we need to check is which one is giving me lesser cost. So let's just create our answer and see what will happen. So what I was saying is, let's just create our answer and see what will happen. So in our answer, as we can see, from 0 index I can jump to position 2 and position 1 only. And earlier I already told you that from position 3 to position 4, sorry, from index 0 to index 2, as we are jumping, we are adding the value which is where we jumped, not from where we started. So from 0th index we are jumping to second index, and we will be adding the value which is at this position. So we are starting from 0, so there must be some cost which is at 0. So initially I'm standing at 0, so there is no cost of standing at 0, so the cost is 0. So from here we can jump either to position 2 or to position 1. So let's just see if we want to update the position value at position 2, what we will be doing. So from position, so for updating the value at position 2, we can jump from position 0 to position 2. We are jumping from 0 to position 2, which will be costing us as 0 plus the cost at position 2. The cost at position 2 is 6. So 0 plus 6, which will be 6, or the value which is already there. It might be possible that we might have came from 1 to 2 with a lesser cost. So it might be possible. This is one of the reason why we need to check the value which is present over here should be the minimum value cost. So there might be a possibility that we may have came from 1 to 2 also, 0 to 2 also, 1 to 2 also. So whichever is minimum we will be considering that over here. So from 0 to index 2, from 0 to 2 we can jump with a cost of 6, and from 0 to 1, see, I can also jump from 0 to 1. So from 0 to 1, the minimum cost will be 0 plus the cost at 1, which is 7. So 7 will be our cost for jumping over here. Initially we can fill this with int max or some other value which is very large, so that I can make it as minimum as possible. So 7 we can jump from here. Now let's just do the same thing with index 1. So from index 1 we can jump to index 2. If you're not getting it, just go with me step by step and you'll get it. So from index we can jump to index 2. From index 1 we can jump to index 4. So let's see which one is giving me the minimum. So from index 1 we can jump to index 2. So from index 1, so at index 1, what's the cost till now, which is 7 is the cost till now. So I can jump to index 2. So 7, I can jump to index 2 with a cost of 7 plus the cost at index 2, which is 6. 7 plus 6, which will be nothing but 13. And see, here we have already updated it with a cost of 6, which is nothing but jumping from 0 to 2. And if we are jumping from 1 to 2, we will have to give a cost of 13. Okay, are you getting my point? So from 1 to 2, if we want to jump from 1 to 2, we should come from 0 to 1, and then from 1 to 2 I can jump. So from coming from 0 to 1, I have to spend a cost of 7, and then from 1 to 2 I have to spend a cost of 6 again, which will be nothing but 13. And I can see I have a better option, which is going from 0 to 2 with a cost of 6. So I'll be not updating this with 13, I'll be keeping it as 6. Now from 1 I can also jump to 4. There's two way where we can jump. So from 1 I can jump to 4. It's basically, if it is empty, it's nothing but int max value, the maximum value. So from index 1 we are jumping to index 4. Now let's just create our answer. Let's just see what we are doing. So from 1 we are jumping to 4. So we need to check 1 to 4, which one is giving me the minimum. If I am jumping from 1 to 4, that means I should be standing over here, and if I am standing over this position, I have already spent a cost of 7. Okay, so what the position is, if this is my answer array, so what we'll do is answer of I, which is nothing but 7 over here, plus the position where we are jumping. From 1 we are jumping to position 4. From 1 we are jumping to position 4. So what's the cost of jumping to position 4? Which is nothing but 2. So answer of I plus cost of NSE of I, this, or NSE of I, minimum of these two. So if I'm jumping from 1 to 4, I need to check the cost where we are standing, which is nothing but 7, and the cost where we want to go, which is nothing but 2. So 7 plus 2, or or the value which is already there. So it's nothing but int max. So whichever is minimum, will be updating that over here. Okay, so this one was this case was for next smaller element. Similarly, exactly same thing will be for next greater element also. We'll be finding minimum of answer of I plus cost of next greater element at I, or next greater element at I. Minimum of any one of these. Whosoever is the minimum, we need to put it in our answer. So from 1 to 4 I can jump with a cost of 7 plus 2, 9. Okay, so from 2 to 3, let's just make our answer, complete this array. So from 2 we can jump to 3. So this is next greater element, so we'll consider this next greater element. So the 2 index has already a value of 6, and we need to jump to 3. 3, if there is nothing, then it is int max. So 3 cost is, jumping to 3 is 4 over here. So 2 is 6, it will be 6 plus 4, which is nothing but 10, and the value which is already at this position, which is nothing but int max. So 6 plus 4, 10. 10 is the minimum one, so I'll be updating this with 10. Now 2 we can also jump to 4. So 2 we can jump to 4. Now what will be the cost of jumping to 4? So from 2 we know we are already standing at 2, so then 6 is the cost. So this is the next smaller element. So 6 is the cost plus cost of jumping to 4. So jumping to 4, the cost is 2. So 6 plus 2 is nothing but 8, and the value which is already there, which is nothing but 9. So whichever is smaller, 8 and 9, will be updating that. So it will be updated with 8. Now here we cannot jump to next greater element as there is nothing. So if it is a -1, we'll skip the next greater element part, and we can see next smaller element can be updated. So next smaller element is from 3 to 4. So from 3 we already have a cost of 10, and going to 4 will add a cost of 2. So 10 plus 2, which is nothing plus is equal, 10 plus 2 is 12, and the cost which is already over there is 8. So 12 comma 8, whichever is smaller will be updating that value over here. So 8 will be remained over there, nothing will change. So now from 4 I don't have any greater element, so I cannot jump anywhere, and neither we have a smaller element, so we cannot jump over there also. So as we can see, this is our answer. 8 is our answer. So minimum cost that will will occur when we jump from index 0 to index n-1 is 8. So this is the way how we will be solving this question. So in my example, as we can see, this is nothing but I am creating a next greater element and next smaller element. This next greater element, we will be using a stack. It's very simple. If you will dry run this example or this portion of code, you will get to know how to find the next greater element. Now similarly, we'll empty the stack, and then we'll find the next smaller element. It's very easy. After doing all those things, we'll create a vector array dp, and initially we'll be adding 0 over here because the initial cost of jumping to position 0 is 0, so that's why I added 0 over here. Now the next for loop is very easy. I already gave you the answer. The next answer will be updated with dp of ngi will be, next greater element will be updated with cost of ngi and dp of I. Okay, my bad. It's okay, right, it's fine. Here it should be answer of next smaller element and answer of next greater element, because we are comparing with these values. Okay, so the answer is here is dp. So dp of next greater element, dp of next smaller element, and cost of next greater element plus dp of I will be updating on dp of ngei or dp of nle. If you'll dry run this question, you will get to know like what we are doing. Everything I have explained over here, this is the exactly thing that we are doing over here. Nothing has changed. We are only adding a condition that if it is -1, we'll not do it because there is no greater element which is present beyond that index. Neither for the same for the smaller element also. So this way we can solve this question. So at last we'll be returning the dp. So if you like this question, please like, share and subscribe my channel, and thank you. I'll be posting more Leetcode premium questions with different tags in near future. So thank you for watching.